Hi guys, this video is all about controlling player objects using a third-person camera. So if you've got a camera that's stuck up on the corner of a room and you have a player in that room, you want to move it relative to where the camera is looking rather than where the player is and you know, their forward and whatever it is axis, then this is the video for you. So without further ado, let's get started after the fade. So forgive my crude drawing, but here is our player character, and it's inside a room with a camera placed up on high at an angle facing down towards the player. Now when you move left and right, you tend to use the forward, move left and right and forward and back, you tend to use the forward and right vectors of the player, which is great if you're, you know, if I'm moving forward in and out there, that's positive Z there, and I'm moving left and right, I move left and right along that axis. But if I have a camera at a weird angle like this, then it's going to look strange to the player if they're not moving in the same direction as the camera is. So what we need to do is we need to compensate for that. So we need to use the forward-looking vector and the right vector for the camera, because if the camera's turned and is looking that way and we've got the player over here, we need to move respectively with the camera. So this is the sort of problem that we have here. So I'm just going to move a couple of things out the road so I can see things. So this is the sort of classic thing. So I want to move the character left, right, up and down relative to the camera. Problem is if I use the player's forward and right vectors, the movement's not going to look right to the player. So what I want to do is I want to get this forward facing vector from the camera and I want to calculate the right vector from it, but I want to get this down parallel to the ground. The right vector is actually good, we can use the right vector, but it's the forward vector that's the problem here. So like I said, if I try and move the camera as it is, and I'll show you, we'll create a one that just uses the player left, right, up, down, all that kind of stuff. It looks weird. So when I move left and right, everything goes a bit strange. So some math. All game objects have these vectors. So we have an axis, we have a y-axis which represents up. So if you look at if you take your left hand and you extend your you extend your left middle finger away from you, you extend your thumb to the right, and you extend your index finger up. This is called the left-handed coordinate system. There's a right-handed coordinate system that looks very similar to this. It looks like that. So in each case, your z-axis is represented by your middle finger, your y-axis is represented by your index finger, and your thumb represents the right, the x-axis, positive in all of these axes. So it's positive z is facing towards you, or facing away from the player, heading towards infinity, and then positive x is along the thumb, excuse me, and positive y is along the index finger. And you see that this is represented here. This is actually that way, just so I could show all the arrows there, but essentially it's the exact same thing. So we have y-axis is up, x-axis is right, and y-axis is forward. Now we can use a little bit of math to get this forward, which is now going to be, so if you imagine our camera, so this is our forward facing vector of the camera, so our camera's looking down like that. We actually want it to be that way, so we can, because it's got to be parallel to the ground, so we want it to be facing this way, not facing down the way. So we need to figure out how to get it into there. So luckily we can do a bit of math to finagle it. So the camera, like I said here, is rotated around the x-axis. You can actually rotate it around, you know, the y-axis, whatever, and we can see that it will be in some weird position anyway. But the problem is, because we want to get this forward-facing vector, we need to calculate where that is in the world. So we need to figure this out. So what we're going to do is we're going to look at what's called the cross product. Now the cross product is when we want to take, we know two values. Let's say we know two values. Well, in this case, we do know two values, and this is what this text is talking about here. We know the rightmost value because that's going to be the right of the camera, because it's going to be rotated that way, and it's also going to be rotated that way. So we know this right vector is going to be the right place. We know the up vector as well, because the up vector is the world vector. It's the world up vector because we want something that's on a flat surface that is our world. So we know that that's the up vector. And then the last thing is we need this forward-facing vector, which of course we don't know. We can't calculate that. We don't know that, but we can calculate it, and that's what I meant to say there. We can calculate it. And the way we calculate it is we use the cross product. We take the up vector and we take the right vector, these two values that we do know, and that will give us our forward vector on the ground. And that's what we're going to do, is we're going to use the cross product. And from there, it's just trivial. It's just multiplying it by, you know, adding a force and moving it around the world. So that's what we're going to do just now. Okay, I'm going to go ahead and create a couple of objects. I'm going to create a plane, which I'm going to make 5 by 5, good enough. And I am going to add a cube. The fun cannot be halted. I'm going to add a cube. Why is that in? Why does that do that? Okay, so I'm going to make that 0, 0, 0. And I'm going to raise them up just a little bit over there, and I'm actually going to drag them over to here, like so. And then the camera, I am also going to move over to here, just to kind of like really play around with the camera. And I'm going to move it up quite high, and I'm obviously going to rotate it around so that it faces there, so you can see the camera preview down here. And then I'm going to go into local mode, and I'm going to rotate that down. So you see that the camera is now facing downward. Okay, and the reason why I went into that is because I wanted it to be rotated locally with respect to the axes of the camera, rather than globally, which means that it's like you can see that's where the x-axis actually is globally. That's not how I want to rotate the object. So that gives us our object there. I'm going to save the scene. So I'm going to create a new folder. So I'm going to create that there, and I'm going to call this third person camera. And I'm going to create another couple of things as well. I'm going to create another folder for materials. And I'm going to create a couple of materials so we can see this thing. So I'm going to create a green material, which I'm going to call green. And I'm going to create another material, which I am going to call yellow, because I'm a programmer and I have no imagination. Answers in the postcard, all that kind of stuff. Okay, so this is going to be kind of yellowish type thing. And then my green is going to be obviously a greenish type thing. And the reason why it's going to be green is because, there you go, it's a nice color. I'm going to drop that on here, and I'm going to drop yellow on there so we can actually see it. So that's our game, if you like, just now. So we can actually see these things. And I'm also going to add a rigid body. I'm not going to add anything else to that, and I am going to drop that in there. And you see that we have a rigid body in the scene. Now, the rigid body, the forward for that is actually here. So that's not very good. So I don't want, I mean, you're going to have to rotate, you're going to have to do the rotations and everything yourself, but I'm just concerning with the movement script, okay? So I'm not bothered about where these things are facing, but the problem I have though is that's clearly not where the camera is facing. And that's what I want to draw your attention to. So I'm going to create another folder called scripts. And inside there I am going to create a C# script called move cube. And I'm going to skip over to here, and I'm going to reload everything. And then I'm going to have my move cube. And so for my move cube, I'm going to do a couple of things here. So I'm going to say that vector 3 forward equals transform.forward, vector 3 right equals transform.right. And then my input is just going to be the WASD keys or the joystick, whatever that is. And then I'm going to add I'm going to add a force to that rigid body. So I'm going to have rigid body. I'm going to call it underscore rigid body because there already is a rigid body which is got to be compatible, and it needed a whole bunch of things. So I'm going to get that inside the awake. Rigid body. Okay, so this is going to be on my cube, so I know I have a rigid body. If I'm not sure of it, I can also do require component type of rigid body, and therefore it will automatically give me that. There, I can get rid of that as well. Okay, so now I have a cached version of my rigid body. And so what I want to do here is I want to create a vector 3. So this is the movement. So it's vector 3.0. So my movement is going to be movement.x equals input.get axis horizontal times speed times time dot delta time. So whatever that is, and then I don't have speed just now, so I'm going to have to create that as well. And then I've got my movement dot z because I don't want to move. I don't want to move up. I want to move along in the xz plane. Input dot get axis vertical times speed times time dot delta time. And then I'm going to do rigid body dot add force movement. And my speed, I'm just going to set this locally here for just now. Actually, I'll do it outside that. Float speed equals 20. Let's see what 20 feels like. It's probably going to be too fast. And I also want to stop rotation as well because I don't want this to rotate crazily. So I'm going to add some constraints here. So I'm going to freeze rotation on X, Y, and Z, and freeze position I'm not going to change. I'm going to leave that as is. Okay, so now when I run this, do you know what I should do? I should add the script as well. I have a little bell. I've got a little call bell. Okay. Move cube. All right. So now the script will move the cube. Okay. So now, why are you not working? Okay. Is it working? I'm sure it's working. It has to be working. Yep, it's working. Speed to 20, time dot delta time is that. Oh dear. Ruh-roh. Well, that's always good when that happens. Let's try that again. Reload all. Sure. What was I complaining about? See, this is why I save things. Where are we? Okay, so this is where our camera is. Nothing in the console. Let's make a velocity change, see what happens there. Okay, here we go. So we're going, it's the wrong way. Like, quite clearly it's the wrong way. I'm moving in weird ways here. So that's obviously not the right way I was wanting to go. The object itself, if I push, where's the camera? So the camera's pointing this way. If I push up, I'm going to go along this axis here. So it should mean that I go, if I push up, I should go along this axis here. And that's exactly what happens. So clearly that's not right. If I push up, I want to go further into the screen and so on. So I want to be able to get the right, forward, and so on vectors rather than from the transform itself. I want to get it from the camera. So I am going to create, so that float speed is good. So public float speed tooltip, the speed of movement for the cube. Public camera cam. So I'm going to call that cam, and then I'm going to say if cam is null, I'm going to say cam equals camera.main. So just in case we don't set it, let's go out into the scene and find the main camera. So luckily for us, we actually have a main camera, so I don't need to set this up. It just we'll just pick it up in the scene because of that couple of lines of code there. And if we wanted to change it to camera 2, then we could do that as well, and maybe that's something you want to try, is have different cameras. It'd be very confusing though for the player if you have different cameras and you can move in different ways, but you know, you don't want to break that 180 rule. Is it the 180 rule in shooting like a movie or a documentary where you break that axis? Anyway, I'm burbling now. So I want to change this here. So this here is wrong. I want to get it so that it is the camera axis. So I can change this to cam.transform.right. Okay. So now it should work for left and right. So when I move left and right, I should go across the screen like this. And I'm still going in and out. Why am I still going in and out? Okay. That doesn't make any sense. Okay. Right, we'll come back to that. All right, so what we want to do is we want to do all our calculations in here. So we have our, actually I think when I did this before, I had to do the two calculations. I actually had to do up and forward to get the rightmost vector, and then I had to do up and right to get the forward vector. So let's do it that way. So it's actually two cross products. And if we need to, we can get rid of the second one, or the first one. Okay, so what I want to do is I want to calculate the rightmost vector from here. So I want to say vector 3 right equals, and then this is going to be vector 3 dot cross, and it's going to be vector 3 dot up, comma, and then it's going to be cam dot transform dot forward. Okay, and then I want to say vector 3 forward is going to be vector 3 dot cross, and then it's going to be vector 3 dot up, comma, and then it's going to be right. So this is now this is us taking the forward vector to get, so we have a forward vector that's pointing down the way, and we want to calculate the one that's orthogonal to both of those. So that one there is going to be orthogonal to this vector, wherever that is, and it's going to be orthogonal to this vector, which is 90 degrees. So in theory, that should be us right. And then we can comment these out here. Oh, do you know what it is? Yeah, that's why, because that's wrong. Okay, so that was the basic one. That's why the other one doesn't work. Okay, so that is our right vector here, and this is our forward vector here. So I'm going to say, instead of movement equals x, so this is just garbage just now. That's why that's not working. What I want to do is I want to say movement plus equals and then this is going to be input.getAxis horizontal. Actually, it's going to be right times, and then all of this, which is multiplied by speed, multiplied by time dot delta time. Okay, so that gives us our right axis. That gives us our right movement. So now, when we run this, if I move left and right, we will get left and right respective to the camera. So now, if I move left and right, I now get my movement left and right respective to that camera. So you see that our movement is now there. So if I bring this down to here, so this is where our camera is, and this is us looking down on it. So that's the same scene there. So if I move left and right now, you see that the player, the cube, is now moving not along the axes, but along where the rightmost vector of the camera is. And then I do the exact same thing for the forward vector. So I do movement plus equals, and then this is going to be forward times input.getAxis vertical times speed times time dot delta time, and that will give us our forward. So now if I run this again, when I push forward, I'll go into the screen, and when I push back, I'll go towards me. Or it will be the exact opposite. Actually, I think maybe if I do this round the other way, so I do right and then up, I get my forward vector. So if I switch directions of the cross product, the cool thing about the cross product is it will give you when you do the cross product, it will give you, depending on the order of the vector multiplication, whether it's the up or the forward, it'll give you the opposite one. So you'll either get that or you'll get that. So if I do it that way around, if I do it the cross right to up, then I should get forward. So when I push forward now, I go forward into the screen, and when I pull back, I go back into the screen. So now everything is based on the camera. Now the great thing about this though is I can, so this is where my camera is just now, I can grab that camera and I can move them to the other side, oops, I can move it to the other side of the board, so the other side of the world here, and then I can do my, oops, I can do my world rotation, and I can bring it back to here. So now we're on the other side, and I haven't changed any code. All I've done is just change the position of the camera, and now it's exactly the same. It fits whatever camera that you want to work it into. So now my object is moving relative to the actual camera itself, and not to the object that you're controlling. And that's sort of third person camera controls, and that's all there is. There's only a few lines of code. And so I said that we could probably get rid of one of these, and I think what we can do is we can actually get rid of this rightmost vector here. So if I'm right, we can get rid of that, and we can replace it with we can actually do vector3 right equals cam.transform.right. I think we can just do that, and we don't need the third, that we don't need that extra cross product. In fact, I'm so confident I'll delete it, which means I probably do need it. So we go back here, and now we do this, and you'll see that, yeah, there you go. So we don't need that extra cross product there, and it's all zooming around perfectly with respect to that camera. So that's it. That's the code there. That's all you need to do to get it to work third person there. So all I do is I grab the camera, I cache the rightmost vector of the camera. I perform a cross product based on the rightmost vector and the world up, and then that gets me my forward vector facing from the camera, so looking out from the camera, but parallel to the ground. And then I calculate my movement based on the rightmost vector multiplied by my horizontal amount that I key in. I move using the joystick, and then the same thing for the forward, and then I add my force, and that's it. It's what, 1, 2, 3, 4, 5, 6 lines of code. Can't say further than that. Hi guys, I hope you enjoyed that video. If you liked it, then like. If you didn't like it, then not like. If you want timely reminders of when I get videos out, then please feel free to subscribe and hit that little button thing that's up there. There's a little button in the bell button thing. I don't know. They keep changing the algorithm. Apparently people are fleeing anyway, so it doesn't really matter. Anyway, so I do value your time, so I genuinely value your time. So thank you very much for stopping by and watching the video. And there's plenty more to choose from. If you like this one and you want to check out my other things, and there's probably suggested videos and all that kind of stuff down there below. But yeah, feel free to stick around or go someplace else. It's totally up to you. Okay, but anyway, so until next time, I'll catch you guys there. Bye bye.